In this video, I'll talk about how to negate a quantified statement, both a universally quantified statement and an existentially quantified statement. Now, this is going to come up quite a bit in the class as we move forward, where we're going to want to either prove a quantified statement is false or assume that it's false. And so what that means is we'll need to get a hold of negations of quantified statements. So I'll start with two examples here. Really one example in the text. This is example 3.7 to sort of motivate this and to give you some intuition for how to negate a quantified statement. So the first statement is everyone likes the movie Cats. First thing to notice is that this is universally quantified. Right? I'm saying every person, so for every person, for each person, that person likes the movie Cats. That's one way to think about this. This is really a universally quantified statement. I'm saying this is true, that this statement, the person likes the movie Cats, is true for all people. Now, what would it take to prove this false? Right? If I say everyone likes the movie Cats, and you want to prove me false, if you want to say that's not true, well, what do you have to show? That's one way to think about how to negate this. So the negation of this, so think about that for a second. How would you prove me false? Well, maybe you don't like the movie Cats, and that would prove me false because I'm claiming everyone likes it. So if there exists just one person that doesn't like the movie Cats, then this statement is false. That's exactly the negation of this. So the negation of this is there is at least one person that does not like the movie Cats. So we'll go ahead and get this in symbols in a second. I'm going to move down to this existentially quantified statement. There is a city whose population is greater than Fort Wayne. So this is existentially quantified. Right? I'm saying there of all the cities, there's at least one city whose population is greater than Fort Wayne, right? So this is existentially quantified statement. And again, what would you want to do to prove me false? Clearly, this statement is actually true in real life, but let's just think for a second. How would you try and prove me false? What would you have to show? What would you have to demonstrate to prove that that's false? That is, what's the negation of this? Well, if it's not true that there is a city whose population is greater than Fort Wayne, then that means every city has a population less than or equal to that of Fort Wayne. Every city has a population less than or equal to that of Fort Wayne's population. Fort Wayne. So, okay, so a couple things here to note. So in this universally quantified statement, the first one, everyone likes the movie Cats, the negation of this was a existentially quantified statement, right? There exists at least one person. There's at least one person that does not like cats. So this is existentially quantified. And then down here, when we had the existentially quantified statement, we wanted its negation, it became right? Every city has a population. And so this was universally quantified. So, all right, to make this sort of abundantly clear and to get some symbols in on this, I'm going to define an open sentence and a set to make this statement like we look at universally quantified statements. So I'm going to say let S be the set of all people, and I'll let R of X be X likes the movie Cats. Then the original statement I can write as, so original statement, I can write as for all X in S, so for every person, R of X. That person likes the movie Cats. So everyone likes the movie Cats. The negation is there's at least one person that does not like the movie Cats. So that is, there exists a person that does not like cats, not R of x. So we go from for all x and s R of x to the negation there exists x and s such that not R of x. Down here, there's a city whose population is greater than Fort Wayne. So maybe I'll let S be the set of all cities. And I'll let, let's say, Q of X be X, or the population of X is greater than the population of Fort Wayne. The population of X is greater than the population of Fort Wayne. So the original statement sorry, I don't need to write statement there. The original statement, every city has there is a city whose population is greater than Fort Wayne was the original statement. So that is, there exists X in S such that its population is greater than Fort Wayne, such that Q of X. The negation was that every city has a population less than or equal to that of Fort Wayne. That is, every city has a population that is not greater than Fort Wayne. So the negation is for all X and S, not Q of X. So right, universally quantified statements, the negation of those turn into existentially quantified statements where we negate the open sentence. So notice that. Same thing is going on here, only the existentially quantified statement turns to a universally quantified statement. And again, we negate the open sentence. So this is true in general, right? Those examples weren't special. Let S be, let me say, let R of X be an open sentence with domain S. Then the negation of for all X in S, R of X, is equivalent to there exists X in S such that not R of X. And the negation of the existentially quantified statement, there exists X in S such that R of X, is the statement for all X in S, not R of X. So this is how to negate a universally quantified statement and an existentially quantified statement. Let's go ahead and look at another example of this. For this, I'll look at example 3.8 from the text. So let's look at example 3.8 in the text. We get two statements. Focus on A first, and we want to express the negation of the statement. So the first statement is, for every integer n, the integer 2n squared plus 5n plus 1 is odd. So what's the negation of this? Would be, so this is a for every integer n, so this would be there exists, or there is some, or there is at least one integer n, there exists an integer n, such that the integer 2n squared plus 5n plus 1 is not odd, or opposite of odd is even. That would be the negation. Right? For every, for all, for each turns into existential. There exists. For some, there is at least one. Let's look at another one. There exists a real number x such that x squared is less than 0. So negation of this, Here I have an existentially quantified statement. So my negation is going to be universally quantified. So I could say every real number x or I'll say for every real number x, not x squared is less than 0. So x squared is greater than or equal to 0. And that would be the negation of this one. So that's the idea. Now, another thing comes along with the universally quantified statement, existentially quantified statements. And that is combining universal and existentially quantified statements. So that'll come up in the next video. I'll talk a bit about that. We can have more than one quantifier on an open sentence, and we get a different sort of statement than either universally quantified or existentially quantified. So again, we'll look at that in the next video. See you there.